Good evening, everyone. Am I audible? Okay. So today we'll be discussing week 8 concepts. Okay. We'll start with the cloning and we'll also discuss streams, functional interface, and type inference. So we have seen how to copy an object using a copy constructor, right? So using a copy constructor, we can create an object from an object. And now we'll see another method of creating a copy of an object. Okay. First, let's see what exactly happens when we do something like employee E2 equal to E1, a normal assignment. So when you do something like a normal assignment, E2 equal to E1, now both E1 and E2 point to the same object. That is one thing to remember. And we'll see how we can actually create a proper copy. I'll take this code. So here you see we have employee class and it has two instance variables, name and salary. And they are primitive types. One is string, but it is immutable type. So let's consider it like a primitive type. And here I have the constructor that takes string and double value to initialize name and salary. Then set name method to set the value of name, set salary to set the salary of employee. Now get name to retrieve the name of the employee. Then we have a main method here creating an object of E1 and the name is Jack and salary is 21,500. And here in the next line, employee E2 is equal to E1. We are assigning E2 to E1. And then what we're trying to do is we're trying to get the name of E1 right after that. And next we are calling the set name method and setting the name for E2. E2.setName as John. Okay. And when we do something like this, E2.setName as John, now E1's name will also get updated because E2 and E1 both are pointing to the same object. So when you update anything using E2, you can see the changes in E1 as well. So now at the end we are printing the name here. So yeah, what's the problem? Yeah, okay. Let me rename this. So you see here the first line is the name that we are trying to get from E1 when it was Jack. So we got Jack here. And then here we have changed the name, updated the name using the set name method into John and using the object E2. And when you try to get the name using E1 or E2, you are seeing that both the whatever the object that is referred by E1 and E2, we are getting the same name, right? This part is clear?
Yes, ma'am.
Okay. So next what we will do is we will use the clone method from object class. So if you look at clone method, we go to object and in class object, the top of the hierarchy, we have something called clone method. Okay. See the description, it creates and returns a copy of this object. So the precise meaning of copy may depend on the class of the object. So when you do a cloning, when you call clone method on any object, what you are getting is copy of that object, but it will be a bitwise copy. So bit by bit, that object will be copied to another place. Okay. So for the primitive values, you won't be having any problem by that. We'll see rest of the things. Yeah, I copied right. So okay. Now see I have my class employee, and here I'm calling the clone method. Clone method, and it is not overridden over here. I'm calling the clone method that is given by the object class itself, this object class. So when I call clone on E1, now E2 is equal to E1 dot clone. And if you notice the return type of clone, it is object. Okay. So as the return type is an object, I will typecast into employee over here. And now E2 is pointing to a copy of E1. Okay. Now E2, we will call the setName method by passing a value John, and we will see whether it is getting affected on E1. You see here? No. So Jack, which was already set as Jack here for E1, it is not affected by the change that we made using E2. So E1 and E2 are now completely different objects, two different objects. If you have any doubt related to uh, this cloning, what you can do now, just go to Python tutor. So in Python tutor, just copy the code, and you will see. So when you create E2, now E2 is so here, from here you see we are creating E2 from E1. We are calling E1 dot clone, and we are getting exactly same copy of E1, right? We have a different object. It has created a new object, and if you see the name and salary, the values are same. That is how the clone works. Okay, it's for name is a string value and salary is a primitive int type. Okay, this is how it actually works. And now when I change the value of name Jack to John here, it is not affecting the event because both are different objects. So this is what we want. We want to create a copy of an object, and it should not depend on each other. They should be independent of each other at the end. Is this part clear?
So it is basically, ma'am, a deep copy, right?
Yeah, it looks like a deep copy because we don't have any object type here for employee. Even though string is there, string is an immutable type, right? So we won't be having any problem. But we cannot call it as a deep copy actually. It is a shallow copy. It is bit by bit copy. And you will see the problem of if you call it as deep copy, then I'll show you what happens in the next code. Okay, you'll understand why we can't exactly call it as a deep copy, but it still looks like a deep copy here because as they are separate, independent of each other, we can think it of like deep copy. So when we have a reference variable, there we will have this issue. See this code here. I have class date, and date has three instance variables: date, month, and year. Here is a constructor to initialize those three variables. Here we have the toString method. This is update method that takes day, month, and year and update the date, month, and year for date object. That is about class date. Okay. Now we have employee class, and employee class has name and salary, and along with that it has a date variable, date instance variable. So this is a nested object. Employee object will have another object of date as well. Now this is the constructor to initialize them. Set name, set birthday, that takes day, month, and year, and it will call the update method of date. Here is the toString method, and here in main method what we have, we are creating a date object, and here we have an employee object by passing Jack, salary, and date, D1. And now employee E2 we have created using E1.clone, typecasted to employee here. We are setting the name and setting the birthday and printing E1 and E2. let's see. So now we have E1 and E2 as two different objects. But if you look at the content of these two objects now, name we have changed it to John, okay, and salary we have not done anything, so it is same. And for date, if you look at date, we have actually updated the date of E2, right? But this also has an effect on E1. E1's date also has changed here, correct? I'll just show with the
Is
diagram.
it because, ma'am, the date is itself like the instance of class itself?
Correct. As it is object, what happens is as we are copying bit by bit, when we have date over here for this date now, it will simply copy the reference itself for the next employee for E2. That's why both the date will point to the same object. It's like the same assignment type. So if you see here, we have D1 and now look at E1. This is our E1. Name, salary and DOB is pointing to a date object. Okay. And we are copying this thing, right? This part. So we are making a copy of E1 and now what will happen to E2? E2 gets a new name, new salary, and for DOB, it is pointing to the same date object of E1 as we are doing bitwise copy. So when you do bitwise copy, DOB, whatever the binary thing that we have there as a reference to the date, that will be copied, right? Basically means if we have something like some address, think it of like some address 10x or something. So the same thing will be here 10x. So both are pointing to same date object. Getting it?
No, ma'am. Sorry.
So see here, we have E1 with name, salary and DOB. And if you look at the type of DOB, it's a date. Date is an object. It's not primitive type and it's not immutable type. It's a mutable type. Okay. So what we have is, you remember we explained about the stack and all. So DOB actually has a reference to the date object, the actual instance. So here it will have an address, a pointer to date object. And when you copy E1 using clone, in this case, what will happen is, as it is doing bitwise copy, bit by bit it will copy. So for the DOB part, what will happen is it will copy the address, whatever the address that we have here, that will be copied to here. Okay.
Okay, ma'am. You are saying, ma'am, since E was itself was like keeping the address of the DOB, so when we are
Yeah.
copying, like cloning E2, we are also copy that date address and not the actual date instance.
Correct. We are not making any copy of the date object in this case. We are only copying the reference, whatever that is here, into the new object.
Got
Clear?
it, ma'am.
Yeah. Anirban, you understood this part?
No, ma'am.
So what?
But what I do is, ma'am, I'll look at the video again. Ma'am, please continue.
Yeah, it's like simple only. I'll just show you. Are you familiar with any other language like C or something?
No, ma'am. Python, yeah.
Okay. Okay, just think it of like we have memory. So this is a part of memory, okay? And if we have some integer value, so that will be stored in bitwise manner. And for other things also, everything will be stored in bit by bit, 1-0 form. Okay. And for something like a reference, in our case, the date object that we have for E1, this part, DOB. For DOB, what it will store is, it will store the reference, the address of The original object of date, not the object itself will be stored here. It will be address of the object. Okay, so that is our employee object or whatever we have here. And when you do bitwise copy, you are exactly copying the same thing to a new place. So for the date, what you will get is the address of whatever the object that you had created earlier. So you are only getting the address, the reference. You are not getting a new object, new date object. You are getting the same address, whatever that we had in E1, that is copied to the new area. Is that clear now?
Yeah, I get it. So let's just say if in the first block integer star p had something like 0x124,
Mm,
then in the second block integer star p would also store a 0x124,
correct.
and this six threes, five threes. Sorry,
Mm.
this is what? This is the address, or this is the value that is being stored.
This is the object. So in our case, we can think it is our date object. And we actually had stored only the reference in our employee object.
Okay.
So in the new employee object, we got only that address part, reference part.
Ma'am,
So both are pointing to same object. Yeah.
I get it, ma'am, but like, why would the date
Mm.
be copying the address? Unlike, say, the name, why would the address be copied? Like, why not the value? For instance,
Yeah.
like John or something like that. Why is that?
That is because our clone in the class object is defined only for copying bit by bit. It won't do the copy, the original copy of objects, nested objects. So when we have a date object, a date object inside the employee object, clone by default doesn't know how to create a new faithful copy of date. It simply knows I have to do a bitwise copy of each of the things that I have in employee. That is the only thing clone knows by now. But we can do this. We can do a deep copy, we call it as deep copy of date by overriding the clone method. Okay,
Ma'am,
for
so
now,
name and salary, it is like for primitives, it is creating a copy, and for date, which is a class, a custom class, it doesn't know how to deal with it. Is that what you're saying?
yeah, for primitive type, when you simply copy to a new part, anyway, clone is creating a bitwise copy, right? So for salary, if we have value 0, then in bitwise also it will be 0. So it is same thing. No issues in that. It is in the new place, but the value is same, but a different memory part. Okay, we got exactly a new copy of salary for employee 2. And in the case of string, string again is a class type, but as it is immutable, for the new employee E2, in place of name, when you copy the string, it actually creates a new string object itself. So there also we don't have any issue. So again, we got a proper copy of name into E2. So E2 and E1 gets a new copy for both name and salary. And now for date only we have this problem because date is not a primitive type and date is not an immutable type. So we only get the reference of DOB into the new object E2. So now E1 and E2's date are same. They are pointing to the same date object. Clear?
Wait a second, ma'am. Ma'am, please correct me if I'm wrong. I'm just running this by you. For the
Yeah.
primitive types, we are having separate same values in different memory locations. We have copied it.
Yeah.
But for when it comes to like classes like date,
Mm.
it doesn't know how to deal with. So what it does, it is basically taking the reference, the address of the location where it is, and that is what that is what gets copied, and not the values like for name and salary.
Correct. Yeah.
And then when we are making a change to this birthday, say E2, it is basically, since it's pointing, it has the same memory location,
Mm,
unlike the name and the salary, which is like has totally different memory location.
mm.
This one has, since it's pointing to the same location, if we change it in E2, E1 also gets changed.
Correct.
Thank you, ma'am. Understood.
Okay. So, so that is the issue that we have now. Okay, here both DOB of both E1 and E2 are pointing to same date object. So you make change to E1's DOB, it will be seen in from E2 as well. Okay. Now, what we will do is we'll do a deep copy. Maybe you have noticed earlier, all the classes that we have that we used clone must have to implement something called clonable interface. Okay, this simply indicate that this class is clonable. So you have to implement the marker interface that has no any methods. Okay, so if you look at clonable, a class implements clonable interface to indicate to the object.clone method that it is legal for that method to make a field for field copy of instances of that class. Simply means we can use clone on that particular class. Okay. Now, what we will do is we will override the clone method in class date so that it gives me the copy of date when I call clone of date. So here, this is the signature. You have to remember this. Return type is object, public, and actually clone method is a protected method in object, so we can make it as public in order to avoid any complication during inheritance and all. And you can use clone anywhere if you make it public. So you make it public, and then yeah, you must throw this clone not supported exception, and then here you can simply call super.clone. So this super.clone will call the clone method of object itself. Now this will create copy of date and return as object. Now you look at employee class. In employee, what we are doing is we will override the clone method. So for that, again, you will implement the clonable interface and same signature, object clone throws clone not supported exception. And here you create clone of employee. So this particular line, this will create clone of employee class, whatever that we saw earlier, just like this. So it will, this part will create, the first line will create only these two things. It will create a new copy. Okay. And now what we have to do is for the date part, there we have the issue, right? That is our nested object, an object inside another object. There you have to clone date part. So you get the new employee over here. This is the clone of, suppose you are doing E1 and E2 and you are creating E2 out of E1. Now our E2 that we created using E1 super.clone, for that particular E2, we will focus on the date of that E2. You take the date of that E2. So in this line, we are simply creating dob.clone, which means we are creating E1's dob.clone, creating the copy of date object of E1. Date of E1. Okay. And then once you get, so if you look at date, here we have proper clone, right? We are calling this clone method. So this will give us a proper copy of date object. And once you get that date copy clone of date object, you are going to assign it to our new employee, this E2, whatever we have created now. For that DOB, we are assigning this object, new birthday. So now, and finally returning the new employee object. You can think it of like we return E2. Okay, here what we did, E2 dot DOB, we have set into new. I'm simply writing this to make you understand, okay? So we are creating E2 out of E1. If we are creating E2 out of E1, now, first what we did, we have created employee E2 out of E1, and this is a shallow copy. Now we are deep copying one level, we are going down into date. So we are taking the date, we want to create clone for the date of E2, right? So what we are doing, we are taking the E1's DOB and cloning it. Now we have a proper copy of date of E1, and now we are assigning that new DOB date object into the DOB of E2 so that we get a proper deep copy of employee object, finally returning new employee. I'll just run this and I'll also show it in Python tutor, okay? So you see here, same thing. Here we have date object, employee E1 with the JAG, salary and D1. We are creating E2 out of E1, E1 dot clone. We are calling the clone method and setting the name of E2, setting the birthday, printing E1 and E2. And now if you see, the date is not affected in E1 when you change it in E2. So here we have E1, DOB is pointing to our date instance. Next, we are creating new employee, and you see here, currently we are in this line number 41, creating a normal copy, a clone of E1. Now we have E2 with us, and next line is 42, 42 where we are creating a new date object using the clone of date. Okay. Now see, we have a new date object, and this date object we will assign it to our new employee instance. Now new birthday is pointing to this date instance. Now our DOB of E2 is pointing to new date object. Finally, we have something like this, E1 here, DOB, this one. For E2, we have this particular object, and DOB of E2 is pointing to a new date object. Now we have completely independent two objects of employee. Clear?
Why are you returning it as an object? We know it is a new employee.
Yeah, actually the clone method of, you see the signature, the signature of clone method from
That's
our
okay.
object like this.
But you can always narrow it down. Object is the most wide, right?
Yeah, right. You can typecast and
Yeah, you
get
can.
it.
You should. I mean, that would be easier because everybody who is making the clone doesn't have to typecast there. If
Yeah,
I
right.
look, if I'm asking for an employee to be cloned, I expect an employee to come out.
Yeah, correct. So you can make it employee here.
That should be the general expectations, or I would say the standard that expected, right?
Yeah, got it. So yeah. So that you just have to call the clone method and you don't have to typecast or do anything else over here. Okay. Is that clear? Deep copy. So you will
Yes, ma'am.
get this
Understood.
kind of, yeah. So you'll get this kind of questions in OPP also. So remember that your class must implement clonable, and when you override the clone method, remember that to throw this exception over here. Otherwise, you have to deal it here. Anyway, just follow these steps and know how to do deep copy. That's it. Basically,
Ma'am,
we are trying to create a faithful copy of an object. Yeah,
ma'am, one question. Actually, go back to the code.
yeah.
I'm not very clear about this deep copy or shallow copy concept. I just wanted to quickly clarify. You can do it now or at the end also. Instead of say line 49, if we had var e2 equal to e1 only, would that have been a deep copy or a shallow copy? Like instead of using
Where
float,
e2 equal to e1, simply e1, right?
right?
That is just a normal assignment. That doesn't even create a shallow copy. So when you say e2 equal to e1, you are simply giving a new name to the object. It's like giving a nickname to a person.
Am I not assigning e1 to e2, and am I not making this is not considered as a copy?
E2 equal to E1 is not considered as a copy. It's just a normal assignment.
Okay,
Yeah.
okay, ma'am. Okay.
You see here, line number 20, E2 equal to E1. Okay. Look at this. E1, E2, we have reference variable. We have only a single object. Both E1 and E2 are pointing to same object.
Yes, that is clear. That I know. But when do you call that a shallow copy, and when do you call that a deep copy?
Shallow copy means we are actually creating a copy of one object. Okay. But problem is, for the nested object, it won't create a proper copy. It will simply copy the reference. And in deep copy, it simply means you are creating a proper copy of an object, including the sub objects or the nested objects. Clear?
Okay, ma'am. Yeah, yeah. I'll come back to this later on, ma'am. Thank you.
Yeah. You just play around with this code. Maybe by that you will understand. Now you are just introduced to this concept, right? That's why. Just initial thing.
Ma'am, where to get this code?
That is in the same drive folder I shared earlier.
Okay, this will be in week 8. Week 8.
We, yeah.
Okay, ma'am. Thank you.
So this is summary. Making a faithful copy of an object is a tricky problem. Java provides a clone function, an object that does shallow copy. However, shallow copy aliases nested objects. Deep copy solves the problem, but inheritance can create complications. To force programmers to consciously think about these subtleties, Java puts in some checks to using clone. Must implement marker interface clonable to allow clone. Clone is protected by default, override as public if needed. Clone in object throws clone not support exception, which must be taken into account when overriding. Okay, that's about cloning. The next topic is type inference. So till now we have seen that Java is a statically typed language. So whenever we want to create a new variable, we will actually specify the data type, right? If you are creating employee E, then employee is equal to new employee. So E is an employee. You specify it, and uh, in Python, you would have seen we don't use this typing, right? So if you write s equal to 5, then data type of s is integer. So from the value that we assign to the variable, the data type is inferred. And we can do the similar thing in Java, but we have one more extra thing. So if you declare some variable like var b equal to false, so this var, this is called as maybe a reserved keyword, or you can consider it like a reserved word. So, but this thing without data type can be used only inside local functions, local variables and functions. So we cannot keep it as an instance variables of a class. We cannot have class employee and where some salary, something like that, because we don't initialize, right, in the class itself. When we create object, we initialize. But in functions, we can use this kind of type inference. And when we use type inference, we have to make sure that this variable is initialized. We cannot simply write var b and semicolon. We have to initialize with some value. If you give a boolean value, that will be considered as boolean. If you give a string value with quotes, then it will be considered as string. If you give a double value, then d is considered as double, and if here contains a float value, so the data type of f is float. And you can give our normal classes also, like manager. If you are creating manager object, you can do with the var keyword. E is inferred to be manager from the right hand side. Okay, so this is type inference, automatic type inference. Yeah, this is very limited type inference, only local variables that are initialized when they are declared. And using lambda expressions also, you will see, and in streams and all, you'll see this type inference is used. uh, from the context itself, it will understand what kind of type that it is going to deal with. You'll see that. Okay, so for now, just remember that type inference is very limited in use, like it can be used only inside functions. And you have to specify the variables with var keyword, and then you have to initialize it. Three things. Just now we saw, right, where some variable e2. So here, though, we have employee e1 is equal to new employee, and for e2 we are not specifying data type of e2 anywhere, but from the return type of e1, which is an employee, e2 is assumed to be an employee type. So that is type inference. Is that clear?
Clear, ma'am.
Okay.
Ma'am, could you just explain it one more time? I mean, I'm not getting type inference. I mean, what is it doing? I mean, I could understand clone. Okay, it's like
Yeah.
self-explanatory. It's like copy. What is type inference?
Type inference is, see this b. Usually, what we do, if you want to assign a boolean, if you want a boolean variable, we'll write like boolean b is equal to false, right? But using type inference, we can avoid giving its data type over here. Instead of that, you can use this var keyword and initialize it. So this is just like in Python, where we don't specify the data type of variable. The data type of the variable is inferred from the value that we assign to it. Correct?
But won't this give error? Compiler errors.
No, no, no. For that, this is syntactically allowed. But the only thing that we have to remember here is we cannot directly do like b equal to false, but we have to what, prefix it with this var keyword. Where b equal to false means b is a boolean variable. See here. What is the data type of B? We have not specified it as integer, right? We cannot do something like this. B equal to 10. Here we'll get the error. Cannot find symbol. And now when you do var where b equal to 10, then this is allowed. But this is not allowed. Cannot infer type of local variable b. But when you give a value, according to the value that you give, the data type of variable is decided.
But
Clear?
then 949, we can't do var b equal to 10, can we? So we can't do b equal to 10. Can we do that?
Okay, that I don't think
Okay.
changing, right? Maybe
No, that won't allow.
this is wrong. Yeah. So already we have set b as string, right? Incompatible type. Int cannot be converted to string.
Okay.
Yeah.
Anirban, have you understood why it is not allowed?
Yeah, I guess Java is strict. Unlike Python, it's not
They, are,
dynamically
no,
typed.
they don't. They have no rules. Whereas Java has a rule.
Yeah, exactly.
It has a rule so that you can depend on it, and all the backend jobs and the more critical jobs will be always written in Java because it is dependable. Now, what she's trying to explain is before the var was introduced in 2018, we had to define every variable that you are declaring with a type on the left hand side. Left hand side is
Okay.
the definition of a variable. On the right hand side is you evaluate and then put that value in that. It is like you create a space in the memory and compute some values and keep the value in the space. Okay?
Got it. Yes,
When you say
understood.
where b is equal, before where it used to be Boolean b, correct?
Yes, I
Which
mean that
was
is what I
yeah.
returned.
What you are saying is I want a space to keep a Boolean. Then there will be some space assigned and then that will be labeled as a B and you can keep whatever Boolean value that you can keep in that slot. If you want to keep a string, then you got to define string B equal to something. So you declare the space or reserve the space, give a name and the type. That is on the left side. The right side, you put the appropriate thing. If it is declared to be a string, you should put only a string. You can't keep a number. You can't keep a Boolean. Correct?
Understood, sir. Thank you. Thank you, sir.
Now, later, 2018, they came with the idea instead of defining it at the, no, it's more of a typing saving. So they introduced the word where, which means the where will not know what it is till somebody is assigned for the first time.
Right.
After that, it becomes that. In this case, the B becomes a Boolean. After that, you can keep only a Boolean there. Either it can be false or true. It can't hold a number. You can't keep a string there.
Uh, got it. I guess one question. Is it only valid for primitive types or like more complex data types?
All. You can say where B is equal to manager. Then
No, suppose we said employee B equal to something.
no, wait. What employee B? Employee B is then you are already defined this employee. Where is a question of where? When you say employee E, you have taken a space for keeping something which is an employee.
Actually, yeah, right. I meant something like that. 50 line. What Swam is writing at line number 50.
Now, what you can keep in E3 is you can keep employee or anybody who is superset of employee or whose element is above employee, which means you can keep a person there. Sorry, person, not person. Employee can be a manager, right?
Subset. You want to say a supertype or a subtype?
Subtypes. Anybody who's above employee can be kept there.
Okay, is that clear, that part?
Thank you, sir. Thank you. Thank you for that.
So I'll go with the next topic, okay? Functional interface. From here, you listen carefully, okay? Okay, first of all, what is a functional interface? Functional interface is an interface that has a single abstract method. Okay, look at this interface F interface. This has only one abstract method, filter. That filter takes an integer value O, and implementation is not given. Okay, return value is a boolean. Now here we have another class, higher order function something, and here we have a display function, a static method display. This is taking an integer array and an object of F interface, a reference actually, it's an interface, right? So F interface, and inside this what it is doing, taking that array and using a for loop, it is iterating through each of the elements of this array. For each int I in the array that we provide over here, it's going to call the filter method. If f dot filter of I, then print that I. Okay, and have we given the where is the implementation for filter? That is one thing that we have to see. Okay, here calling the filter method for each of the I, and if that satisfies this filter condition, if it is giving a true, then it will be printed out. These two part, and look at this particular main method. In main method we have integer array 1 2 3 4 5, and here we have created an object of even filter. So that means even filter would be a class that implements the F interface, right? And as it is implementing the F interface, it must implement the method that is offered by interface, which is filter. So here what it is doing, taking the filter, taking the integer value, and it is checking whether that integer value is even or not. 0, sorry, it is O, right? O mod 2 equal to 0. So if it is even, it will return a true, otherwise it will return a false. That is the implementation for the filter method from the interface F interface by this class even filter. And come back to main method here. Here we are creating an object of even filter, and here we are calling the display method. This method for integer array we are passing this array. Okay, and for the second argument F interface F, we are passing an object of F interface even filter. This one we are passing this particular object. Now if you connect this with F interface here, now you can say that F interface is holding an object of even filter, and we are actually calling, when you call F dot filter, it is actually calling even filter dot filter, this particular function, right? And it will work accordingly. If it is even number, this will return a true. So here this condition will become true, and it will print that I which is coming from the integer array. So once we complete the iteration of this array, we will get all the even numbers from our array. Is the story clear?
Yes, ma'am.
Okay. Now you look at this particular, again come back. In F interface, we have only this abstract method filter. Okay. And as we want the definition of filter, what we did is we created a separate class that implement the F interface and then given the implementation for the filter. And whenever you call the display method, you are actually passing an object of that event filter, right? And it is taking, for the filter function, it is taking the implementation given in this particular class. That's what's happening here. Now, what we will do is, Java has given us something like this, where instead of creating a new class that implement this functional interface and give an implementation, we can directly give the definition for this filter function using lambda expression. What is lambda expression? Anonymous function, like functions without names. We can call it like this. I think you would have seen in Python also. So look at this same interface we have here, functional interface, and here we have a display method, same in taking integer array and reference of f interface, and here we are calling the filter method. Okay, and you see in the main method, when you call the display method, you are passing the array, and here we are passing a lambda expression. Okay, so this is actually the lambda expression is actually the implementation for this particular filter function of f interface. So when you give this lambda expression over here, what happens is this filter will work according to this particular function that we give. So here you see the syntax, you open bracket, closed bracket, here it is the argument. If you compare it with the previous one, filter takes an int value, right? This int value. So this is the input argument, and then you have this arrow. After arrow, you give the body of that particular function. So there you would have seen return I mod 2 equal to 0, right? So same thing. You can avoid return also, because by default it knows that it has to return the value of this expression I mod 2 equal to 0. So this will return either true or false. So this particular part is going to be the implementation for this filter. Getting it?
Ma'am,
Yeah.
I hate to sound like the problem child here, but I'm not getting it.
It's okay. Like where you have confusion, you can ask me question, then I'll be able to explain more.
Ma'am, actually, this is the first time I'm like having Java or any coding language apart from Python, and this is like I am getting lost in the code first, and these are like going way over my head. I'm really sorry. Well, I'm saying it the most respectfully, ma'am. I'm not getting it. Please don't get me wrong.
No issues, no issues. I understand. You see, uh, okay, one more point is, you see the class name higher order function, right? What is higher order function? A function that takes another function as an argument. Okay, so a function that takes another function as an argument. And now if you look at display, here what it is doing, the display is taking another function. This is a function actually, right? Another function as argument. So that's what we are going to implement. If you remember, in Python we had this map function, right? MAP map. So in map, what you will do, you will pass a function something like square and some list, and what you will get the result of the square function applied to each of the elements of the list.
Yeah, and it created a new array, of course. I remember that, map. I know map Python. I remember that.
Yeah, so we can relate it with this. So map takes a function and an iterable. If you look at this, so map of square and numbers. This square, this is a square function, right? So we are passing the square function and the iterable numbers, and we will apply the square function over each of the numbers and we'll get the list of squared numbers.
This is
Okay,
understood now. Yeah, I know this.
yeah. Now let's see the lambda function for this. Look at this. So instead of passing the function square, okay, we have a named function. Square is a named function, right? And lambda function means it doesn't have a name. So in Python, you started with lambda, right? So this particular, whatever that comes before the comma, this is the function similar to square function. But here what it is doing, taking two values, x and y, and then adding it, returning x plus y. That is the meaning of this line, lambda x comma y colon x plus y means it is taking x and y and returning x plus y. Similar to a function behavior, correct?
Okay, ma'am. I'm not familiar with this one though, but okay. Yeah, I take it.
Yeah, it just, you can understand. I'll just explain it again. So map is going to take a function and apply to the iterables. So instead of square, we have a something like anonymous function, a function without a name. The definition of function is given here itself. So this function, this anonymous function, we have to write it using lambda. So lambda, we simply means it simply means it is a lambda expression or lambda function. So this is a function that accepts two arguments x and y, and it should return x plus y. And now we are passing list 1 and list 2, two iterables. Now what will happen is it will take list 1 and list 2, take the first two elements as x and y, 1 plus 4, add it, and we'll get the 5. It will next take 2 and 5, get 7, and 3 and 6, 9. So basically applying this particular function over each of the elements of this iterables.
Yeah, understood, ma'am. Thank you.
Yeah. Now let's relate this with our code. Same thing, but as it is Java, you will see more data type and all over here, more keywords, etc. Let's see the filter over here. You can relate it with the square function that we had there. Okay. And now what we have is an interface with one single abstract method filter. Okay. And in Java, what happens is here in display method, as we have array and this f interface def, it is taking an object, a reference of f interface, functional interface. And for filter function, we need an implementation, right? If you want to call filter over anything, you need an implementation for filter. And if you look at the entire code, you don't have filter function defined anywhere. Previous example, I showed that I had a class that implemented this interface and has given an implementation for filter. That's what I used over there, right? But in this code, I don't have a class that implements this interface and giving an implementation. I don't have a class. Instead, what I'm going to do is I'm going to use this lambda thing, the anonymous function. What I will do is for this filter function, just like what we had x plus y there, here we know that display is going to take an object of f interface, which simply means that Java will infer that this f interface, as it is having only one abstract method, whatever the function definition I receive here is an implementation for the filter function. So when I call a display function with an array and a lambda expression, this lambda expression will always be an implementation for the abstract method that is coming from the f interface. Because F interface, as it is a functional interface, the specialty of functional interface is it will have only one abstract method. Only one abstract method. Okay. So this abstract method need an implementation. So that implementation is given directly here through a lambda expression. Getting
It
it?
cannot, ma'am, it cannot work with two abstract methods, right? There has to be
No,
only one.
only one. For this lambda expression to work with functional interface, an interface, there should be only one abstract method. Only then it will directly assign to filter, right? Otherwise, it will get confused. So whenever I give some function definition here, for which it will give implementation for the only one abstract method that is coming from the F interface. Are you able to relate? We are giving the implementation over here for what? For the only one abstract method filter that is coming from F interface.
Ma'am, I understood line 15. I can relate with that lambda thing, right? It's going to filter all the digits whose remainder is 0.
Yeah.
Right, I get that. But I am not able to relate uh, that line number 6 and how line number 2 is into line number 6.
Okay, I got it. Yeah. So look at display. Display's arguments are array and an object of F interface. I'm just calling object, okay? But we don't have an object of interface. I know you know, everyone knows, right? But still, for understanding purpose. So we have F interface F, an object of F. Now, always remember that the function that I have here, this interface has only one abstract method filter. Okay. And now, when you call display function over here by giving a lambda expression, this is the second argument for display, right? Now F interface F is containing this lambda expression. And for what it will assign? It will assign to the only abstract method that it has, filter. F interface has only one box of filter. And now F interface has got this lambda expression. So it will fill this filter method. Getting it?
Yeah, I think I'm getting it. I think I'm slowly starting to get. Um, okay, so basically that F interface that you're saying is working like lambda, where we defined lambda and that was x plus y. We are taking two corresponding elements of x and y and we added them up and we created a third new array. That was what you showed us, right?
Yeah.
Here what is happening is that once we are invoking the display method in line number 15, first of all the array is getting passed on to, right, integer array. That is okay, that is fine, that's easy. Then for the F interface, this is that lambda function or the corresponding lambda function equivalent that we are defining. Now we could have easily had given I mod 2 not equal to 0, anything like that. We could have defined it any way we would have liked, right?
Yeah, we can define any way. We can give any implementation for filter. So whatever that we give here is going to be an implementation for the filter. That's why when we are calling the filter method, we are actually processing in this manner, I mod 2 equal to 0 or not.
But ma'am, just one question. Why do we need an interface? We could have just called it like that only. Why need
No,
line
the thing is,
1 to 2?
only then it will be able to connect with the filter method. So when we have simply a lambda expression, then it won't work independently. It always needs a functional interface with an abstract method. So it's like a combination. So lambda expression always works with a functional interface. So you give a lambda expression, this should go as an implementation for some abstract method coming from a functional interface.
I think, ma'am, he is asking what if we don't even have that interface? Like why can't we just filter on the
I mean,
way?
we are using in line number 7 and 8, we are taking the array, and for every I in array, if f dot filter I, uh, yeah, f dot, where is that filter? Ma'am, in line number 8, sorry, can you explain like f dot filter I, what is it doing? I mean,
Yeah. So yeah, okay. I think you are saying we can directly do if I more 2 equal to 0 over here. Is that what you said?
no, I'm saying
No,
keep
right?
the code as it is. No, but you said that like if you have to include the lambda function, we can't do it without an interface. So I guess an interface would be required. But
Yes.
I'll take your word for it, ma'am. I mean, I'm new to this, so I just please thank you for understanding. Line number 8, ma'am. Can you explain line number 8?
Yeah. Here we have f interface object over here, interface, and we are calling the filter function of that interface. Okay. This is an abstract method. Directly we don't have anything, an implementation here. But for the filter function, when we call this filter function over here, which implementation we are taking? We are taking this implementation that we passed. We'll take the I and it will check I more 2 equal to 0 or not. And if it is true, then this will print over here. So we are actually giving the implementation for this filter function through this lambda expression. Shall I show one more example? Like where it will be useful?
Yes, ma'am. Please.
Then we'll come back again. So let's take some string array and I'll add some So you remember this sort method that comes from arrays? Arrays dot sort by passing SA. I'll print each of the string we have to import the package util. Okay, see here we have the string array and here I'm calling sort method, and once you call the sort method over this string array, it will sort this array on the basis of alphabetical order for strings. So we are getting apple, banana, kiwi and pear over here. Okay, and let's see arrays dot sort. You see here these are method overloaded methods. Sort can take byte, double, float, anything. And sorry, what happened? Yeah, and it can take object, can take here you see it can take some T array and a comparator. So if you look at comparator, So this array, this sort method is going to take an array and comparator object. We don't know what comparator is. Suppose here you see we are sorting in ascending order, right? And if you want to sort in descending order or based on the length of the string or something like that, you can actually do custom sorting. You can change the way the sort actually sort these values. Okay, for that, what we have is this comparator interface, and comparator interface has something called as compare method. You might be remembering this from comparable interface, right? Comparable interface has compare to, like it will compare two objects. And here also the compare will take two objects, O1 and O2, and compares its arguments for order. So same thing, compares its two arguments for order, returns a negative integer, 0 or positive integer, as the first argument is less than or equal to greater than the second. Similar to that, if x greater than y, it will return 1 or positive integer, same. Now, what we can do is we can actually change the way it sort the string by giving a new implementation for that compare, because sort will by default it will use the compare that is actually defined. To sort it in ascending order, we can give a different implementation for that compare method over here. For that, we don't have to create a class and then implement the compare and then pass that object over here. Instead, we can simply give a lambda expression over here on how to compare two string objects. So we are giving a new implementation on how to compare two string objects. So here what I will do is I'll sort based on the length of two strings, length of the strings. So I'll give s1 and s2 as argument of our lambda expression. Take s1 and s2, and then s1 dot length, using the length function we can get the length of the string, right? Minus s2 dot length. So when s1 is greater than s2, you will get a positive value, and a negative value opposite, 0, same. So according to this, so this you will see the same result. No, this is opposite, right? Yeah, here it is doing the opposite. Yeah, here it is doing opposite. So descending order. If you want descending order, you can just reverse it. So that is how it works. So what I want to say is, what we done here, we passed a lambda expression. We passed a lambda expression for what? For the compare method that is coming from comparator. This particular interface comparator. It is a functional interface. A comparison function which imposes a total ordering. Comparators can be passed to a sort method to allow precise control over the sort order. We can change the order, custom sorting.
It is, ma'am, similar with interfaces, how we used interfaces to implement inside different classes and then use that in our like how we want to use that.
Yeah. So instead
So
of creating,
we want to customize the thing so that it's helpful.
we are actually customizing. Yeah. So here comes the use of comparator. The functional interface and lambda expression. So if you look at the comparator itself, we have many functions, right? Comparing double, long, equals, natural order, many things are here. And compare is that abstract method that comes from this comparator interface. So this can be used for other classes also, like our user defined class. Here too I used a string only. Are you able to understand what is the
Yeah,
purpose of?
I get it, ma'am. One question, ma'am. A higher order function is something that a function that can take another function as an argument.
Yeah.
So here arrays dot sort. When you use it this way with a comparator, it is acting as a higher order function.
Right.
Okay, so arrays dot sort has the capacity to also act as a higher order function.
Yeah, because a method overloaded. So there is a sort method that can take another function also as the second argument.
Yeah, understood. I got this part now. Clear. Thank
Yeah.
you.
So okay. Here too it's completely defined. Instead of s1 dot length minus s2 dot length, each case is separately given. You can also directly give some function like this. Suppose we have something like a map of string and integer, some marks, create a hash map. Okay, and then I am going to add uh, some marks. Okay, now I will call, or what will I do is I'll not directly put it. I'll call the merge function. Go to the package right here. I'll call the sum function from integer. So integer dot sum, the utility function, the static function from integer. So this is just like the lambda expression that we have seen earlier. Instead of that, we are directly passing the function that is defined already in some other class. Instead of x comma y arrow x plus y, we are passing the function. So see, merge is a higher order function. This is taking another function as an argument. Simple, right? So look at this. So we have map of in string and integer, and here we have Anu with 30 marks, Nevin with 70 marks, and here we have another name Anu and marks 100. Okay, and now we are calling the merge function on name by passing name, this name, and this marks too, and this is our function. Okay, and what is the purpose of merge? What will merge do? Merge will check in the map whether Anu is actually present in the map, if it is already present as a key, then it will take this particular marks 100 and it will add with the previous marks that this particular map has. Okay, so 100 will be added to 30, 130 and updated the value of Anu, the value of Anu. And for Nevin, what will happen? So we don't have anything, right? So it won't do anything. So only for this Anu, this will happen. Merging will happen. So that is the use of merge. Anyway, what I wanted to say is about the merge function using a lambda function over here. Actually, this is a method reference. So another function is already defined. Sum is defined in integer class. This is passed as an argument for merge. So see here, merge function takes key value and a by function. Some other interface might be some remapping function. Anyway, we have to pass another function over here as the third argument for merge. If the specified key is not already associated with a value or is associated with null, it will associate with the given non-null value. Otherwise, replaces the associated value with the result of given remapping function. So that's what happened here. It replaced the marks by adding with this particular mark because we have given this function on how to do the merging operation. Getting it?
Yes, ma'am, got it.
Okay. So many languages support higher order functions, passing a function as an argument to another function. In object-oriented programming, this is achieved using interfaces. Encapsulate the function to be passed as an object. Java allows function to be passed directly in place of functional interfaces. Interface consists of a single function, functional interface. Lambda expression describe anonymous function. Cannot pass lambda expressions in general. Only when the argument is a functional interface you can pass. Can pass a method reference if the lambda expression consists of a single function call, as we saw now in integer sum for the merge function. Okay. Is that clear till now? Shall I move to next one? Next topic? This will be easier. You don't have to think much from streams. See this. This is a normal array list, and here we have these values. How we are processing this array? So count equal to 0. We are trying to find the count of even numbers from this list. Okay. So what we are doing, we are taking a for loop, looping through each of the elements and checking whether IMO2 equal to 0. And here we had a count variable. We are incrementing each time we get an even number. Finally printing the count. So here we have 2, 4 and 50 as even numbers. So we got 3 as the output. Okay. This is a normal way of iterating through the elements of an array. processing, some doing something over here. Now we have something called as streams. So what is stream? Stream is like a more like a declarative way of doing something on collections. Okay. So what we will do is we have collection. We'll convert that connection into a stream of objects. It's more uh, like a pipe. Like you get some data through it. What you will do is you will apply this stream function to the collection, and you will get an input stream. Okay. And once you get an input stream, you can apply any kind of transformation over it. You can apply filter function. Many functions are available. Filter, map, many things. So you can apply those operation or the transformation operation on this stream and then get the output stream. So the specialty of stream is it doesn't have any storage. Stream is not a data structure that stores elements. Instead, it conveys elements from a source, such as the data structure, an array, or generator function, through a pipeline of computational operation. Just look at this image. We give the input stream, apply this intermediate operation, and then we will apply the terminal operation, and then we will get the output. Okay. Let's see how to do that. First of all, what we need is this stream, right? We need that stream. So same list, I'm taking the same list of numbers. First we have the collection, and what we will do is our list name is numbers. We'll call this stream method over that. Stream method is a method that is present in collection interface. So this will return us stream of numbers that is present in this list. Okay. And to that stream, we are applying the filter operation. This is our operation. So what is the purpose of what is filter method doing over here? Filter is like normal filter that we have seen in Python. It will take the operation, whatever that we give here, and apply it to each of the element of the stream. So it will take the element, and then it's a lambda expression again. Take the element, check whether it is even or not. Only those even numbers will come out of this filter. So what will filter return? Filter will return a stream of even numbers from this input stream. Okay. After that, next dot count. Next method is count. This is the terminal operation we are applying. This means you will count the number of even elements returned by filter. Getting it? First we had numbers collection, then we got input stream. We are converting that into a stream of numbers. Then we are applying the filter with this lambda function. So this is the filter operation that we will do. So we'll get even numbers after that. List of stream of even numbers, not list. Okay, this will be stream of even numbers after filter. Then we will get count of number of even numbers. So what will be the output? We'll again get 3. Is that clear?
Ma'am, here count is inbuilt operation, like inbuilt method.
Count is there, sorry.
Inbuilt method.
Yeah. Count is coming from Yeah, this is an interface stream, and we have all these functions like, where is count? Count is here. Count. For each we have map, we have limit, iterate. We'll see all of this. Skip, take while, drop while. All these methods are already present in this particular interface. So if you look at count, the return type is a long. Returns the count of the element in this string. Clear?
So ma'am, in this case, we are using filter as a like a boolean type. So if true, then it's return a value something. So it gets stored in a counter. So what if we don't use filter? Then we can't use count. Another
Then,
filter was there.
yeah. So in this case, if you don't use filter, you will count the count of number of elements present in the first stream. So you see how many numbers are the 3, 6, 9. So we got 9. So we are directly counting the number of elements present in this stream returned by numbers.stream.
It's okay, ma'am. I am asking if the filter type is not boolean, like if it is something else, would it also work then? If the return type is not boolean?
No, then it won't work, right? So filter is defined in such a way that it returns stream of elements after applying that filter function that we give. So filter will always return a stream of same type that we give. It's not returning the boolean value, it's returning stream of values itself. So you see here in the next example. So here directly
Can't
stream
we,
filter.
inside my filter, can we use like more complex type of functions?
We can use whatever the function that is given by this particular interface. Okay, those which can be applied to a stream object that we can use, not just filter. You see here, filter, after filtering, what we are doing is in the returned stream of numbers, we are printing each of the element. So that for that we have to use this for each method. Take each of the element that comes from the stream, print it. So here we are getting the even numbers. So what is filter doing? Filter is applying this function to the stream of numbers that we get over here, and if it satisfies this particular condition, it will add into the output stream of filter, the resultant stream of filter. Clear? Clear?
Ma'am, in this case, the filter is storing the stream objects because it is a true boolean type, right? Like it is passing the boolean case.
Right.
What if it was not a boolean?
Then it won't work. So filter is defined in such a way that so it can apply this function to that, and only if it is returning true, that elements will be filtered and put into the output stream. So you have to
Okay,
return
so
a
we
boolean
we
value.
can't just we can't just arbitrarily use any type of function there.
Right, right. You can't use something like, so this, you see, incompatible types, bad return type in lambda expression.
Yes, ma'am, understood. That was what I was asking.
Okay, fine. So so you see in filter has, hope you have seen from here. So filter is taking a predicate, right? The predicate. So go to predicate. Predicate will have an abstract method. Here we have the abstract method is called as test. Okay, we are actually giving that lambda expression, this lambda expression now, this one. We are actually giving this lambda expression for this abstract method test. See the return type, it is boolean. So it should match whatever the return value that we get using the lambda expression should match this return type.
Yes, ma'am. That's what my query was. Like, if it is not a boolean, that it how it going to store that thing? It doesn't
Okay,
make
you
sense.
understood, right? No?
Yes, ma'am.
Okay. So this is how you can print each of them. And next we will see map. So we have map function also. So what map will do? Map will apply this function, the lambda expression that we give, to each of the elements that is coming from here. Okay, so what we got after filter? After filter we have only that even numbers, right? What were they? 2, 4 and 50. So we have 2, 4 and 50 after this filter operation. Now take 2, square it, we'll get 4. Take 4, square it, we'll get 16. And for 50 we'll get 2500. So it will take each of the elements from the resultant stream of filter and apply this operation on that. Now printing whatever that is that we got after map. Map will also return stream of elements after applying this operation.
Ma'am, what is the purpose of this like modular approach? Why we are not like describing it as a function and then calling it?
Yeah, so this is you remember the first module like imperative and declarative style. So this is actually declarative style. We are not focusing on how we are doing this operation. Rather, we are simply focusing on the result of that. So now we know that filter function will take some function and apply to the elements and get the result after filtering. Map function will take the elements and apply the function on each of the elements and get the result. So we don't want to know how this is actually working. Even if you look, it's confusing, right? You take map function, map will take some function interface. Function itself has, it will have some abstract method. See the apply method. So this lambda expression that we give here is actually going to be implementation for this apply method, this abstract apply method coming from function for map function. You see the layering, but we don't have to worry about anything. We just have to know that we can use like this map. For using map we have to give a function lambda expression on how we actually want to map each of the element of the string. We want to square it, we want to square each of the element of that string. Getting it?
Yes, ma'am.
Okay, so we learned stream, filter, map, and for each. For each is to print each of the element. Okay. Again, for each also we are passing a lambda expression. What does it mean? Take each of the I, print it. See this for each. Here again, some interface is given, consumer. And if you go to consumer, consumer again is a functional interface. It will have an abstract method, accept. Perform this operation on the given argument. So which operation we are giving? This system.out.println. Take the I and print it. Now you are able to understand, right? What is the relation between lambda expressions and functional interface?
Yes, ma'am. It is
All the,
like we don't need anything like fancy, but first describe things and variables. we can just get the result on the way, like more fast, quicker.
Yeah, right. In code will be shorter and we'll get the result properly. Okay. So next, what we have is, sorry. So here we are actually going to generate some numbers. Okay. So here stream of double random numbers. We are using this generate function to generate some numbers. We are calling the random function from math. So random function, what it will do? It will give us random values between 0 and 1, right? So as this particular generate will generate in an infinite manner. So it's not going to stop. Hmm. So I'm not going to run it again. Okay, this will generate without any limit. And next we can, what we can do is we can generate with a limit. Generate random numbers with a limit. So generate math random, and you have this method called a limit. Again, if you had noticed here, you would have seen that L limit returns a stream consisting of the elements of the stream truncated to be no longer than max size in length. Max size is the value that we give to limit. So if you limit to 10, you will get first 10 random numbers generated by the generate function. Okay, so you got the first 10. So we have a limited using the limit function. And now that is generate. And here we can do it in another way also, creating numbers. So iterate. Iterate is another function. So that will take starting value and how it has to iterate, how the next element should be computed. That is to be given in the second argument for iterate. So you take n, then add 1 with it. So first it has started with 0, right? So 0 plus 1, 1 will be the next number. 1 plus 1, 2 will be the next number. So 0, 1, 2, 3, 4, 5. So here we have another function called skip. What skip will do? Skip will skip first 10 elements that is returned by this iterate. And then again it won't stop reducing. Then it will take the next 20 elements. So here we have limit 20. So the next 20 elements will be taken after skipping the first 10 elements from the stream. Then printing. So can you predict what will be the output?
It will print from 10 to 20 numbers.
10 to, yeah,
Means
20 will be there.
index from index 11 to 20.
29.
Yeah,
10 to
next.
20.
Yes,
20
next.
elements.
Yes.
Yeah, correct. So that is iterator with skip. Now, in this without skip, okay? limit 20. So what will be the output for this?
Till 19, ma'am.
Yeah, 0 to 19. Okay. So next we have two more
Ma'am,
important
can you again explain the significance of each stream? Why we are using it?
streams are used. So iterators and all, every time it is difficult, right? We have to process things through iteration. But stream is very easy to do, and it provides a lot of functions to do things easily. If you compare this itself, if you have to count the number of even elements using the conventional method, using the for loop, how many number of lines it takes, that itself is one thing. Here we have simply defined many functions, so you just have to use it. More like a declarative way. So we are going more into that side, from imperative to declarative side.
So we can't use all these like ready-made functions without a stream object.
No, without stream we cannot use these ready-made functions.
Okay, ma'am. Understood.
So here, so take while you look at this, we have first created numbers.stream, and this take while is just like our while, okay, normal while. So this is like take while this condition is true for the numbers that is coming from the string. Okay, so our numbers 11, 21, 31, 41, 1, 2, 3, 4, 50. And here the condition for take while is already defined. It is already defined on the top, okay, same list only. Okay, take while. So first element that we get from the string will be 11. And we will check 11 is greater than 10 or not. Yes, 11 is greater than 10. So we will include this in the output string. So 11 we will get. Next 21. It will check with 21. 21 greater than 10. True. So that will be included in the output string. Then 31. 31 greater than 10. True. So included in the output string. 41. Again, 41 greater than 10 is true. 41 is included in the output string. Then we have 1. 1 greater than 10 is a false. So we stop there. We stop there and we won't check the rest of the elements. Okay, even though you see 50 over here, this is not coming inside our output stream, right? Because we stopped right over here. Once the condition becomes false, we stop there. We don't process the remaining elements from the string. So you simply read it like an English statement. Take while number is greater than 10. Is that clear?
Yes, ma'am.
Out. And then we have this drop while. So here I have assigned it to a different variable called drop. Okay, stream of integer. This is going to return a stream of integer. The underline stream will always maintain the underlying collection. So as it is integer, it will be a stream of integer. Now drop while n is greater than 10. Opposite of that. So you take 11. 11 is greater than 10. Drop it. Don't consider. You go to next element. 21. 21 greater than 10. Drop it. 31 greater than 10. Drop it. 41 greater than 10. Drop it. 1. 1 is not greater than 10. From there, from that point, you take every element that comes after that. 1, 2, 3, 4, 50. That's why the output is 1, 2, 3, 4, 50. Getting it? Just read it like drop while number is greater than 10. Once the condition becomes opposite, from there you start printing or taking all the elements from the string. Clear?
Yes, ma'am. Clear.
Okay. Rest are same only. I'm not repeating. Okay. So that is about stream, and you will see we have not discussed flat map. We'll discuss flat map in next after you learn optionals from week 9. Okay, and stream is very important for OPP exam also. Till now we have seen only stream of integers and all, right? The teacher is not defined now. Look at this. We have class teacher with name and experience as two instance variables, a constructor to initialize name and experience. Here we have main method with the main class with main function, creating list of teacher t list, new array list of teacher, adding new teacher objects t1 3.5 experience, t2 name 4.2 experience, t3 2.6, t4 3.4, t5. We have added 5 teacher objects into this list. Okay, and now we are going to process this particular t list using stream. So t list dot stream. So this will return what will be the data type? It will be stream of teacher, right? We'll get stream of teacher. Now once we get that stream, then we are applying a map operation. What we are doing, we are taking each I. What will be each I?
Teacher object.
Teacher object. Take teacher object, then what we have to do? Take experience and check whether it is greater than or equal to 2 and less than or equal to 4. This is greater than or equal to 2 and how is and work here? Between 2 and 4, right? Yeah,
Yes,
it
ma'am.
should be
Including 2 and 4.
yeah, including 2 and 4. So this except T5 everything will be true. Then what we are doing, then after that we are printing each of the L, whatever the value that we get from here, applying the operation. Something is wrong. What is this? Okay, T2 won't come. Yeah, right. Yeah, that's why I got confused. Okay, T1 3.5. So for this it will be true. 4.2 it will be false. 2.6 it will be true. 3.4 true. 1.5 false. Okay, correct only. So we are applying the stream operation on list of teacher objects. Okay, is that clear? So I just want to show we can apply stream for user defined class also, not just the primitive types and all other uh, like Java defined types. For everything we can apply the stream.
So, ma'am, line 19 and line 20, they are both different operations, right? They are not
No,
together.
they are together only. So it's more like tlist dot stream dot map dot for each together. It's more like this.
Oh, okay. I thought it is something else.
So just for readability, you just put in the next line. Okay.
Okay, ma'am, understood.
So you practice as much as you can. Quiz 2 is also coming, right? Next week, right?
Yes, ma'am. 23rd.
23rd. Okay. So we'll conduct revision sessions also. So before coming to revision session, you go through all this. Just do these examples. Just practice it. Uh, be familiar with the syntax. Okay. You would have seen new things like lambda and all, stream, and yeah.
Ma'am, why did
See,
type? This is type interface, ma'am. What you just did?
sorry.
Was this type interface? What you just did?
Yeah. I was
Why didn't work?
yeah. Why I wanted this is I want to show that this for each now for each is not returning anything. Okay. I just want to show that. So look at the return type of for each. For each returns void. Return type is void. So you won't get any value to be stored into some variable. So you will see such kind of things in quizzes where uh, some variable will be used to assign the value of for each. So remember that for each doesn't return any value. So you cannot assign the result of for each into something. Okay.
But then what will we do with that output?
For
Suppose
each
if
is directly processing over here. Whatever the function that we give here, it will apply to the each of the element of the stream that we provide.
no,
That's
I
it.
get it, ma'am. It's going to like do some filter, some selection, some sorting, or something.
Mm.
So, and it will generate an output.
Yeah.
So, what will I do with that if I can't store it?
For filter and everything, you can store into a stream. Filter you can store. What I did is the last part. The terminal operation over here is for each, right? This for each is not returning anything. This only you can't store into a
I get
variable.
it. I get it now. I mean, you mean to say that it won't be required apart from printing on the screen output purpose. It won't be required.
Right.
Or even if it's used in some method, some kind of operation, then that output will be processed by any other variable or something like that.
Yeah. For each will process only whatever that we give. That's it. And if you want to store into something, you stop it. Don't use for each. You have to stop here and then assign it to stream of. So here what will be the output? Boolean, right? Capital Boolean. Because map is going to return Boolean values, right? So that should be the data type. What is the return value of the operation that we give?
We have
So
also
whenever
always we have always have to check the last end of the
ha,
expression, right, ma'am?
yeah, the last terminal operation, what it is returning. For
But
example, for count, it is long. So if you are applying count and if you want to store the return value of count, you declare a variable of type long.
do we really have to mark this up and remember all of these?
Not all of this, but for each filter, map, these you have to remember. Iterate,
For each filter,
while,
map, what else, ma'am?
take while, drop
Take while, then
while,
what else, ma'am?
skip, limit, limit, skip, iterate, generate also you have to remember.
Skip, limit, iterate, then generate.
Ha. Filter you noted, right? Filter is very important. Count. Map is also important. That's it.
It would require lots of coding practice to remember this thing.
Yeah, a little bit is required. Otherwise, it will be difficult to remember.
So, ma'am, if you're done, I have a question.
Yeah, yeah,
Ma'am, can you please just explain deep copy and shallow copy, please?
yeah. I'll try to get some image. Yeah, this one. Where is it? Look at this. Also related with the example that we discussed, employee. Okay, employee which has date object. So date object. Okay, date object is something called as a referenced object. In this case, okay, we can relate with this reference object. Original object is E1, cloned object is E2. Okay, E1, E2, and our date object, which is actually a referenced object in E1 or E2. In shallow copy, what will happen? Both the original object E1 and the cloned object E2 will point to same date object, the referenced object.
No,
Okay.
I got this, ma'am. This part I'm clear about. Like when both of them are referencing the same object, that's going to be a shallow copy, and when they have separate object, that's going to be a deep copy. What I'm trying to understand is that there was one particular question in the in quiz one, and I
Mm,
messed it up. It was about that library, books, Java, Python, and that question.
mm,
So it is about the implementation and like what, which part, which code means what, which lines of code means what. So when I do an equal to this, and then it's actually getting them in action. That is what I get it. Like shallow copy would be when both are getting referencing the same, and deep copy will be when both are they have nice separate, address memory locations, right?
okay.
It is my doubt is with regards to the implementation part. As to when we see a code, which line means what? Like with this would mean a shallow copy, and this would mean a deep copy.
Yeah. Do you have
No,
that code?
are you referring to that question where we had to like deep copy the array for a given student,
So
something
there
like
was
that?
one question with the librarian Python. I just this
Use word.
well, yeah, it was
So
this, this
in
quiz.
case of arrays, since they are mutable, so in that case you have to implement them differently for each object, right? Are you saying that thing?
One sec, please. Give me a second. Sorry, I'm just searching for that question and found it.
You found it, huh?
Yeah, I found it, and but the thing is that I just need to one sec. Hmm, it was that library wala question. How do I share an image or like?
Yeah. I got it. I got it.
You got it, ma'am? That class library string name, town library.
Yeah, yeah. 1 second. I'll share my screen. 1 second.
That question itself has to do with the data structure of arrays itself, how they are implemented, right? So that's what.
This one, right? Screen is visible, right?
Yes, ma'am. I think this one.
Yeah. So library has name and array of books, and here we have a copy constructor that takes L. And here in copy constructor, what we are doing, name equal to L dot name and books equal
It
to
is
L dot
it
books.
is a shallow copy, right, ma'am?
It is a shallow copy. Yeah. So here we have a string array, Java, Python, C++, and L1. We are creating L1 object by passing city library for name, and for books we are passing this array. Okay. Now, L1, the books array of L1 will point to this array, and in the next line, library L2 we are creating using copy constructor L1 by passing L1. So we are using this constructor. So if you look at the constructor here, what we are doing, name equal to L dot name. Okay. So for name, you will get the copy of name from L1, and for books, books equal to L dot books. So as it is array, this assignment will simply make the L2's, the books array of L2 to point to the same array that L1 is pointing to, the same array. Getting it?
Since arrays are mutable, that's what they are doing
Yeah,
in the
yeah.
backend.
As array is a mutable type, it will be just as a, it will be just an assignment, a normal assignment operation. It won't create a new array. We have created B array, and then we are creating object first L1. L1 name is city library and books is pointing to this array B. Next, L2 is created using copy constructor L, but the implementation of this copy constructor is in such a way that it is doing a shallow copy. It is not doing a proper copy of books. It's not going to create a new array for the new object L2.
Ma'am,
What it is doing,
for name it is going to create a new thing, but for books it is going to reference the exact
yeah,
existing
whenever you
variable.
create an object, whenever you create an object of library, you are going to get two variables, name and books. And for the value only, we are focusing on the constructor, right? And in the copy constructor, what's happening? For the name, for L2, you are taking the name of L1, L1 dot name. L dot name will take L1 dot name. So you will get a new string over here, city library for name. Anyway, this will be going into what, that string pool, those kind of things. You don't have to worry about string. As it is string, anyway, name is going to get, you can think it of like a new name. Okay. In
Since
this, in
since ma'am,
object,
since strings are like not mutable, so that's what we are not referencing the E1's name. We can just reference that, but we are not doing that. Instead, we are initiating another variable for name for the like L2 and then assigning its like copying the existing name value.
yeah, basically this will point to the same names. And whenever you make change to this name for the second object, that is not going to be reflected in the previous one.
So
Yes,
for
ma'am. Yes.
names, it is going to be a deep copy, and for the books array, it is going to be a shallow copy.
Right.
Oh,
So books is going to point to the same array. We can't
and
technically
why
call
is
it as
that?
a for
Why is
name
that?
also,
Why is that?
because here we have
Same
made
mutable,
assign.
mutable and immutable nature of things. That's what it is designed like. Sir told us, right? This sir discussed this thing.
I
So
missed
just
the
like
discussion. Seriously, I'm so sorry about it, ma'am. Can you please explain?
this is exactly similar to how we are doing in employee E2 equal to E1. So E2 and E2 both are pointing to same, because employee is an object type. String array is an object type, an mutable type. So both books of what is it? L2 and L1 is pointing to same array.
But
All
ma'am, you said that that was not a copy at all. When employee E2 equal to E1, that was not a copy.
no,
Oh, ma'am, I'm
same
not.
thing is happening over here. So when we say employee E2 equal to E1, we are naming, giving a new name to the E1. Now E2 and E1 both are pointing to same object. Same thing is happening here for books. So when you make books equal to L dot books, so this books belong to L2. L2 dot books equal to L1 dot books. What will happen? Both L1 and L2, both books will point to same array. So if you want to do deep copy, then you have to use a for loop and copy each of them, or use the method from arrays, the copy method. You have to do something extra here for deep copy. But now this is shallow copy because only the reference is copied. When you write books equal to L dot books, only the reference is copied.
For this to be a deep copy, you have to initialize a new array and then copy all the book names into that
Individually.
array.
Is it okay?
Okay, ma'am.
What you can do is just copy this code and put in Python tutor and try to see the changes. Okay, you will see the object how it is changing and all.
Ma'am, can you just quickly show me like what the arrow means? I mean, that would be easier for me to get when I run it.
Arrow is like the pointer. So B is a reference variable.
B is a reference variable. L1 is also a reference variable.
L1 is reference variable.
Okay, and there is a gray arrow which is pointing to array.
Yeah. So B is pointing to the object this array. Okay.
Got it, because
L1
it is line 15 says that.
B line 50. Right. Yeah. So left hand side the reference variable is in the frame
And then
and the right
ma'am,
hand side
L1,
objects are,
line
yeah.
16, ma'am, L1, how do I take that?
So this is in the halfway. I'll complete it. Okay. L1 is this reference variable pointing to the object of library that is here. Okay. L1 is pointing to object of library and it has name and books, two fields. Name contains city library.
Books is
Books,
empty.
yeah, books again is a reference variable.
No, it's
So
empty or like what is it?
no, it is a reference variable. It is having a reference. It's carrying a reference. It's carrying
Like
address
a
of books
address.
object.
Okay, okay, I get it.
Yeah. So that's why here the dot and arrow is pointing to an array over here. Okay.
The
Now
whole
L2,
business of ma'am, yes, ma'am, go on, go on.
yeah, you say.
This whole business of deep and shallow copy, we are dealing with this thing so that whenever we are copying a thing and we are like doing some operation on that copied thing, we don't like intentionally or unintentionally want to infect or like do some other behavior operation on the other object that we copied from, right?
Hmm.
We are copying from an object, but we don't want to affect it by dealing with the second object.
Right.
That's all.
Our objective is to create a copy of an object, but a complete copy. But in this case, it is a shallow copy, not a deep copy. So the complete copy I meant is a deep copy where the nested object is also copied properly. We get a proper copy of nested object. But books, in this case, we have not got proper copy of books. What we got is a reference only. So books of L2 is also pointing to the same array where L1 is pointing.
So whenever we are into a copy constructor and for the primitive types, those will be shallow copied, and for data structures like array or others, uh,
No,
They,
you are wrong, I guess. Try again.
sorry, my bad, ma'am. Let me rephrase that. What I'm saying is that for primitive types like int, string, and all that,
Hmm.
whenever we are doing this, when we are executing line number 17, L2 new
Hmm.
library L1,
Hmm.
that would mean that it is creating a deep copy.
Yeah.
And for arrays and other like not complex data types, it is going to do a shallow copy.
Hmm. So if we make a copy and if it has a field which we call it as shallow copy now, then the whole copy is a shallow copy.
Ma'am, can you repeat that one more time, please?
So in this case,
Uh-huh.
we can call either it as a shallow copy or deep copy, right? We
Yes.
can't call name did a shallow copy and books did a deep copy. We cannot call two things in the same object.
We
All
can't.
in all, it's a shallow copy
Why can't we call that? Because
because books is not copied properly, right? For books, we have not got a proper copy of array. So
oh, I see.
this
That is why we cannot call. That is why we cannot call this action as a proper deep copy or shallow copy, whatever.
right, it's a shallow copy. After all, it is a shallow copy only. If we have not got a proper copy, a faithful copy, then it is a shallow copy.
Okay, ma'am.
So
You
Understood.
see
if
in
every
this
field is
question,
copied properly, then it is shallow copy, a deep copy.
ma'am, when we are like updating the next L2
Mm.
and we are updating its name and then also updating the books or the array.
Mm.
So we are seeing that affected also in case of L1. Name remains same. The name is
Yeah,
not getting affected, but the
yeah,
book array gets affected. So we
correct.
don't want that. That's what we want deep copy.
Yeah.
That's the purpose.
Is it okay? A bit.
Yes, ma'am.
Okay. So shallow copy duplicates an object's top level properties, but any nested objects are still shared as reference with the original. Very proper sentence. Whereas in deep copy recursively duplicates all objects and nested structures, creating a completely independent replica copy.
So essentially, if we had to do a deep copy, then we would have to run a for loop in that case.
In this case, yes. Yeah.
Just merely assigning L2 equal to new, sorry,
You can create a new array.
yeah, yeah, got it.
And then you can use a for loop and copy each of the string elements into the new array. Okay.
Okay, ma'am.
This point also. Changes to shallow copies nested objects will also affect the original, while changes to deep copy will not.
Understood. Thank you.
Yeah. Okay. Then we can stop this session, right? Okay. Thank you. Thank you, everyone.
Ma'am, one question, ma'am. You just stop the recording, ma'am.
Okay. Yeah.
Ma'am, the your